This is our second video on sketching trig functions. Now we're going to start with sketching functions that involve a change in amplitude and a change in period. So if the general form of the trig function is y equals a sine bx, then in this case here, this example here, what is a? 3, that's the amplitude, and b is 2. So therefore the amplitude is 3 and the period is, what's the formula for period? 2 pi over b, remember? Which is 2 pi over 2, which is pi. So the period for this is pi. The other thing you can say is I can fit 2 sine curves in the normal period. Okay? So I'm just going to sketch this from 0 to 2 pi. We'll just mark out evenly on the axis some points. So here we go. We've got 2 pi, pi. Okay, actually, just better be careful there. Sorry, I don't like to do that, actually. Just one sec. Okay, what I normally like to do is the period is pi. So instead of taking 2 pi to do a complete curve, it only takes pi to do a complete curve. Now, in an exam, you don't have time to sit there and measure out. We don't expect that you do. This is what I would do if I were you. You still just draw a normal sine curve. So you go up, down, up, right? Up, down, up. Now, the reason, so you just draw a normal one. I wouldn't put my scale first and then draw it. It just makes it a bit hard. Look, you can if you want, but I just go, right, that's pi. This is 2 pi, because I know that my period is pi. I don't have to make this look any bigger than what I would normally draw it. Why don't I just go 3 and -3? You don't actually have to go 1, 1, 2, 3 and have it all the way up there. You can just draw a normal sine curve. See, what I would do, just draw it how it comes freely and naturally to you. Draw the curve and another one, because you have to go from 0 to 2 pi, and the period is pi, so you can only fit every full curve goes up to pi, and I'll need another one because I'll have to go from 0 to 2 pi. And instead of just trying to make it really tall, that's when it starts getting messy, you just put 3 and -3 and you're done. It doesn't have to be to scale. You just have to draw it that that's 3, that's -3, and whatever. So here we've got pi and 2, here we've got 3 pi and 2. So therefore, where are our turning points at? Do you remember what turning points are? Pi on 4, yep. Well, this is half pi, that's 1 pi, this must be. 3/4 pi, 3 pi on 4. And this is between 1 and 1.5, which is 1 1/4 pi, which is 5 pi and 4, and have a guess what you think the last one would be. Looks like it's going up by 2/4 every time. All right. And what are the intercepts on the x-axis? Be careful. For that domain from 0 to 2 pi, what are our x-intercepts? 0. Don't forget 0, because it starts from 0 to 2 pi. I want it in that domain. 0, pi and 2, pi, 3 pi and 2, and 2 pi. Okay, they're your intercepts. So here we're doing a question where we're involving a change in amplitude and a change in period, okay? Really, I think to sketch the curve normally as you would and then just put your scale on after you've drawn it is much easier, because you can just draw it like freely. Okay, if we look at the next one, we've got y equals 2 cos x on 2. The a is 2 and the b is, because this is of the format y equals a cos bx. What have we got? Yes, the half is the coefficient of the x. So what's the amplitude? 2. And the period is 2 pi over b, which is 2 pi divided by a half. What's 2 divided by a half? 4. So your period is 4 pi. Now, but a normal period is 2 pi, isn't it? So you don't want, so if I don't want to draw the whole thing, that's 4 pi now, the whole thing. But you're only supposed to be sketching it from 0 to 2 pi. Do you get what I'm saying? So if I do start sketching this, That's where 2 pi is. The rest, I'm not going to do it, but that would be the rest if I did do it. Does that make sense? So I only want it from 0 to 2 pi. What's my amplitude? So instead of putting 1 and -1, what do I put? 2 and -2. So here, if this is 2 pi, this is pi. Okay, so I'm only going from 0 to 2 pi because that's what they want, only from 0 to 2 pi. Okay, make sure you finish right there. Okay, so the turning points are at where? X is 0, and where else do you have a turning point? At 2 pi, and your intercepts on the x-axis are just at pi. Okay, with this one, actually, I'm going to make you sketch a few things here. We're going to sketch y equals negative cos x, and after that, we're going to sketch y equals negative cos x minus 1. Okay, we're going to sketch them both. But let's just sketch y equals negative cos x, okay? What do you think it is? It's the cos x curve flipped upside down, basically. When it's supposed to be 1, it's -1. When it's supposed to be 0, it's 1. And when it's supposed to be -1, it's 1. So look, what I'm going to do, I'm going to do a quick sketch of the normal curve. Looks like this, like really lightly, so you can barely see it. So I know instead of doing that, what am I going to do? So I've got -1 and 1, but instead of doing it this way, 0 is still 0. See, because you could do a table of values if you wanted, but when it's 1, it's now -1. Does that make sense? When it's -1, it's now 1. So it actually looks like this. Now that's y equals, so I would just draw it and then put your 2 pi, your pi, here's your pi on 2, here's your 3 pi on 2, there's your -1, there's your 1. So this is the graph of what reflected in what? It's the graph of y equals cos x reflected in the x-axis. All the function values have changed sign. So where it was 1, it's now -1. Where it was -1, it's now 1. That's negative cos x. What if I asked you to sketch negative cos x minus 1? What would you do with that curve? I would just shift it down 1. So y equals negative cos x minus 1. I'm going to do that in purple. So instead of -1, it's now, instead of 0, it's now, right? Instead of 1, it's now 0. Instead of 0, it's now -1. Instead of -1, it's now -2. So the other curve, a bit hard to draw, would look like this. This would be negative cos x minus 1. Okay? So if you were asked to draw it, you've got to really, you're taking 3 steps to draw negative cos x minus 1. You're thinking of what y equals cos x looks like, then you're reflecting it in the x-axis, and then you're shifting it down. So you could have a really faint one there, a faint one here, and then you actually draw your proper one. Okay? I don't sit there and go negative cos of 0 minus 1 equals. Negative cos of pi on 2 minus 1 equals. You don't do that. All right? You'll be there forever. You need to build it. You need to build it up. What does cos x look like? What does negative cos x look like? What does negative cos x minus 1 look like? Okay? If it was negative cos x plus 1, you would shift it up from where it was. Or if it was 1 minus cos x, what if I asked you to do 1 minus cos x? Isn't that really just, what's that? 1 minus cos x. It's negative cos x plus 1. So if you saw that, you would just say, well, that's negative cos x plus 1. That's up here. Okay? If you want to draw those others. Even though it looks like 1 minus cos x. Okay, so in red, you've got 1 minus cos x. This is y equals negative cos x minus 1. And the one in the middle is y equals negative cos x. Okay? So just build it from your cos x or from your negative cos x. You can sketch, I'm sure, 1 plus sine x quite easily. You know what? Maybe I'll change this one. Just cross that one off. We're not going to do 1 plus sine x because we know that that is just the sine x curve shifted up. That's easy. Let's do this one instead. Y equals the sine of x plus pi and 4, and we're going to sketch it from negative 2 pi through to pi. So, all right, don't get your ruler out. Let's just think about it. Did the amplitude change? Okay, so basically it's going to go from 1 to negative 1. I'll just put some markings there, 1 and negative 1. I'm just going to draw these really faintly so I go the right height, okay? And now, all right, we've got to decide which way to shift this curve. It is the sine x curve, but it's shifted. You've got to decide which way is it shifted. Is it shifted to the left or shifted to the right? What makes, where does the sine curve normally start from? 0. What value of x makes this sine 0? Negative pi on 4. So instead of the curve starting and going like this, right? It's not going to start from there. You know what you can do? You can actually draw it. Sometimes it's easier to draw it. Instead of calling that 0, you'd call it, you'd call it negative pi and 4. But the problem is it's starting there and you'd have to get rid of this line. But remember, you choose where to put that axis. So that's another way you can do it, is just sketch it, but you put in the axis at the end, not at the beginning. Makes it easier. It really does. But look, if this was the normal curve, if it was, this would be 2 pi, this would be pi, that would be pi on 2, and that would be 0. But now it's got to move to, so I'm just going to space these out. I don't know if I've, oops, one sec. No. All right, just one. Normal curve is like this, 0, pi, 2 pi. What value of x makes this 0? It's negative pi and 4. So what I need to do to each of these values is take away pi on 4 from each of the values that are on the original curve. So 0 minus pi on 4 is negative pi on 4. Pi on 2 minus pi on 4 is pi on 4. 1.5 pi minus 1/4 pi, sorry, that's my mistake, is, sorry, that's that one, sorry. Pi minus pi on 4 is 3 pi on 4. 1.5 minus 1/4 is, minus 1/4 is 5 pi on 4. And this one is 2 pi minus 1/4 is 7 pi on 4. So when x is negative pi on 4, negative pi on 4 plus pi on 4 is 0. That gives you the 0 that you're originally supposed to have. A 3 pi on 4 here plus pi on 4 is pi. That's where sine pi was originally. Okay, so 7 pi on 4. The problem is I need to keep going. So what I also need to do is put my axis and move it over here and put my 0 there. Now, sine of, when x is 0, I get sine of pi on 4. Well, that's 1 on root 2. And this is an amplitude of 1, and down here is negative 1. Now I need to keep going up to 2 pi, so I continue the curve just up to about there. Sorry, it just keeps going up. There's my 2 pi. I do not keep going. Okay, I stop it there. Now when I come back, so let's see, I need 1 complete. 1 complete has to stop here as well. Do you get it? I don't need this last bit. Yeah, I need to go over the hump and stop equivalent to there, which I'm doing. So this is negative pi on 4. What would this one be? Just have a look. That's pi on 4, that's negative pi on 4. This is 3 pi on 4, this is negative 3 pi on 4. No, it's not. What is this one? Negative 5 pi on 4. This is negative 3 pi on 4. This is negative 7 pi on 4. And this is negative 2 pi. Negative pi on 4, negative 3 pi on 4, negative 5 pi on 4, negative 7 pi on 4, negative 2 pi. Tricky. Very tricky. I don't know, girls. All the years of doing this, I prefer to sketch the curve and then put the values in and then lengthen and shorten on either side. I find it easier. It's just too hard otherwise. It's really natural just to sketch the curve, then write the numbers in. Otherwise, you're writing the numbers in and trying to sketch it. It's a nightmare, believe me, I've tried it. Well, my brain can't work like that. Don't know about yours. I just think it's easier to sketch. So therefore, this here, that was the original graph, and then I shifted it from there sort of here. So it's the graph of y equals sine x, translated pi and 4 units to the left. It has a period of, look at the front, it still has a period of, the period was never changed. See, we've added or subtracted something to the x. It's not 2x, and it's not x on 2, and it's not 3x. So the period, it still does take 2 pi for a complete revolution. Like, not revolution, but a complete period. Period is still 2 pi. It's not condensed and it's not expanded. It's just shifted. Okay? The amplitude is still 1. And where are our intercepts? We've got negative 5 pi and 4, negative pi and 4, 3 pi on 4, and 7 pi on 4. They're the x-intercepts from negative 2 pi through to pi. Okay? We can also see where the turning points are, but I didn't ask you to do those. But you can see where they are as well. Last one we're going to look at here. Y equals 3 tan 2x. So, tell me, I know I tell you amplitude, that tan doesn't really have one, but you can stretch it. You can stretch the tan curve, even though it has really no specific amplitude. But it is going to be stretched. So, y equals a tan bx has, one sec. I'm just going to go a is the amplitude. Oh no, and period? What's wrong with me? What's the period? Pi on? No, the graph y equals a tan bx has basically the amplitude, well, I'm just going to call it a stretch factor of a. And what's its period? Pi on? Pi on 2. But there, oh, for this one. Pi on b. No, that's the graph y equals a tan bx. All right, so for the graph y equals 3 tan 2x, what's the period? Pi on 2, and I'm just going to go 3 times the amplitude. Got it? It's going to be 3 times as high as what it normally would be. The amplitude's not 3. That means it stops at 3. Okay, let's go. 3 times what it normally would be. Do you get it? Yeah. So instead of, you know where you've got tan 45? Yeah. It's 1? Yeah. What would tan 45 be? But I've got a problem.
8 times amplitude?
3 times A's amplitude. No.
In the first line.
8 times the amplitude. Whatever. That'll do. Don't worry. Okay. Normal amplitude. Whatever. Okay. Let's go. Okay. Period pi on 2. What is the period normally? Let's just draw it. I'm just going to draw it the way I like. You know what I would do? I wouldn't try and draw it bigger, smaller, squashed up, higher. Don't. Just change your numbers that you draw. But it normally does look like this. So let's just start sketching it like this.
So are you making it go from 0?
I'm not sure what I'm doing yet. But this is what I'm doing. I'm just sketching it. And I'm not even sure how many I'm doing. Now, girls, normally it's pi on 2 this time, the period. So from there to there is pi on 2 this time. It's not pi. Do you get it? This is one full graph. So if normally this would be pi on 2, negative pi on 2, what's this going to be now if the whole thing is pi on 2? This is pi on 4, negative pi on 4. So tell me, if this is another pi on 2 added here, what's this? From there to there is pi on 2. What's 1/4 plus a half? This should be 3 pi on 4. This should be negative 3 pi on 4. And I just have to add a little bit more. See, this would be pi on 2. This would be negative pi on 2. This would be negative pi. This would be positive pi. Do you know which way you're going to draw? Down or up? Down here and up here, up. That's what your curve looks like so far. But I haven't taken care of my amplitude thing But all I've got to do is substitute a nice little value. A nice value would be something like, let's try pi on 8. When x is, do you know why I'm choosing pi on 8? Because there's 0, there's pi on 4, which is a quarter, halfway is an eighth. Let's have a look. What is 3 times tan of 2 times pi on 8? Isn't that just 3 times the tan of pi on 4? So if x is pi on 8, which is halfway between 0 and pi on 4, I would have 3 times tan of 2 pi on 8. That's the same as 3 tan pi on 4. What's 3 times tan pi on 4? 3 times 1, 10, which is 3. So pi on 8, all you need is a 3 there. What about here, negative pi on 8? What do you think I put?
Negative 3.
That's it. That's all you need. So I just want the point here. Pi on 8 is 3. Negative pi on 8 is negative 3. That's all. Even just one of them would be fine. Do you get what I've done? When you sketch something like that, and you've got that amplitude of 3, it is not enough just to sketch it and indicate no scale on the vertical axis. You have to indicate some sort of scale. And the obvious point part to go, because you know that pi on 4 is, tan of pi on 4 is 1, you go, well, what will make this pi on 4? It's 2 times 10. It's 2 pi on 8 is pi on 4. That's why you choose pi on 8. And it makes sense to go halfway between 0 and pi on 4 anyway. Okay?